Okay, kids. Bob N1KPR. I just did a video on how to make these panels. I've received a lot of, a lot of queries have come in. People questioning how this is done. So I just put that up there today, and here it is, another pre-selector-ish thing. And if you look at part one, this of course is part two of the peak and notch adventure. In part one, I showed you the how to build the peak and notch. Whenever you have a peak, you need a notch. You're reminiscent of the old Q multiplier stuff we used to fool around with in the tube days. The beautiful old Hammerlins and Allied kits and so on. I think even Lafayette too, if I'm not mistaken. Maybe you want to write me about that. But here's the thing. With its tune, band switch, and bypass filtering, and you've seen all that in the first video. I've built the shielded case. This is a plastic case, and it's covered with copper foil tape. There's a stainless steel cover for it. I don't know where I got this. I made this plastic box here. Styrene, it's all been copperized. And I had this cover somewhere. I built the box around the cover. And if you notice on this cover, I have some pieces of music wire, spring wire, that have been soldered to the inside on both ends. And I brought them out through the hole and kind of made a little, just bent them flat on the ends. And they're going to contact the top cover, which is going to also be copperized. I just made up a word. To keep the ground continuity and the shield's integrity good. So this is probably how it's going to be. I'm not sure yet. I've got the preamp in here. The peak and notch here. Here's the toroid for matching. And we're going to have that. So we can go from half a load, or double load, actually 25 ohms, up to 600, which would be a 600 ohm ribbon, balance line, or if you're using an in-fed or something that's way out of whack. Anyhow, it's a tuner. Like we use tuners for transmitting. It's an impedance matcher. The preamp I've got here pre-wired out of the box using the old Retma standard, yellow input, blue output. Remember that? And here's the attenuator pot, and here's the gain pot for the actual 15 dB, 7 to 1, 6 or 7 to 1. That's plenty. Don't go crazy with gain. You'll hate yourself. You'll have nothing but intermod and overload and all kinds of bugs running around the head end of your radio. Don't do it. 6 or 7 is great. 15 dB, 10 dB is fine. I've got a protection board. I'm not sure I'm going to use this. I probably will. This is a very basic one. I've got the bleeder resistors here. The obligatory and requisite back-to-back double diodes. There's an NE2. I'm cap coupling. This is about 1.5 microfarads total, so we get down into the VLF band. So there's no DC coupling over here to the blue output. This will be the yellow, obviously, going to the input switch. This toroid has been tested and tested and tested. I can't test it anymore. It's type 37 material. I think that's a 3/8 ID. it is virtually lossless. I can measure loss, yes I can, but it's so minor. I wouldn't lose sleep over it, really. And of course, we want something that sort of gets overlooked a lot. We want a nice, clean power source. So here's the power supply. It's regulated 12 and 9 volts. The 9 volts, of course, for the varactors, they don't want to see 12 volts. So 9 is going to limit that. 9 volts will bring me down to about 5 or 10 picofarads in varactor capacitance, so that's fine. You got plenty of cap filter. I got RF bypasses for each stage. A good beefy transformer, so we don't sag anything. And what I don't have here, that's going to go in this spot, is a pi filter that will further clean up the DC. Hang on, let me show you that. Alright, it took me about 5 minutes to find it, but through the miracle of technology, I didn't bore you at all, I hope. Here's the pi filter. You see it. All it is pointer here. Focus, baby. Okay. Cap input with a RF bypass. I think that's a 5 or 10 amp or 7 amp choke. And I think it's around 20, I don't remember, 20 or 40 microhenries. And then the repeat here with the cap and the bypass. So it's just a it's just a pi filter that you're gonna. Here's the back of it. This is an old board from our old company I hacked up. No good to anybody, so put that in. That will give me, and if you've seen my other videos, you'll know that'll give me sub-millivolt noise coming in on the B plus the VCC here and over here. Ladies and gentlemen, sub-millivolt noise from an AC linear transformer power supply. Without it, we're going to be anywhere from 2 to 5 millivolts out here, maybe, of hash, ripple, hum, I don't know. Look at it on the scope, you'll see it. Run it through a good pi filter, and you will be almost as clean as a battery, and I dare anybody to turn this system on and tell me if it's running from a battery or the AC mains. The other thing is, and I don't have one here to show you, but you see in some of the other videos, when you do the input from the 120 or the 220, whatever you're using, use one of the filtered things or build a filter. Hang on, I have one. I'll be right back. Well, I don't know where I put the one that I made. I think Fred Sanford came and took it. But here's the guys I'm talking about. This is a commercial one. EC input. This is for 110. There's the, let's see. If you see the schematic. Schizophrenic. Oh, there it is. But anyhow, I bought the components to make these, and actually a little bit better than the quality of these, although these are good. I've never had one fail, but I like heavy duty. Bulletproof is always nice to have. And what they'll do is they'll keep the common and differential mode noise that's coming into your transformer. They're going to keep it out. And that's a good thing, because we're dealing with what, gang? What are we dealing with here on the input? Microvolts. And if you're doing DX and weak signal, you're working with fractions of a millionth of a volt. Less than 1 microvolt. So what you're doing over here at 100 and something volts, you don't want that hash getting into the system, especially after you've taken all that time to shield everything and keep it nice and quiet. So quiet. All right, gang, that's it. Went really, really long. I always do. That's my trademark. We love you all. Stay safe, gang. In one KPR, bobsamerica.com. Bye-bye.